Greetings and salutations. So this one is a response to a comment I got from a earlier video, and what specifically this is responding to a question: can you shoot in both directions? I guess the cat is also curious about this. Oh wait, no, she just wanted to hop up on some boxes. It's fine. Alright. So, what I did is I used the region command, which basically allowed me to organize all of the code by doing region, end region, and this basically made it to where it would not look like this. Like, I'm just going to click this real quick so you understand exactly how absolutely nuts this looks when you have no organization. Hope your eyes aren't bleeding. You see all that? That is what I did not want. So we're gonna go step by step, region by region, and we're gonna hit this, and by the end of it, hopefully you should understand exactly how what I did works. So the first thing I did was I organized the region to be based on the image X scale, and if it's negative or not, and if I'm fully powered up or not. I then put the core attack values that we're using down here, and these are basically so that way I know, okay, when it's not powered up and it's attacking, what's the direction that's going, how fast it's going, what does that look like. So I have that, so no matter how crazy the numbers get anywhere else, I always have a foundation that I can build off of. And as long as you have a foundation that you can build off of, you're going to be okay. Because this can get very, very convoluted very quickly. The moment you go beyond just shooting one attack or just doing one attack, you start introducing more variables and stuff like that. Now, someone, I forget who, but someone said the statement, why not do it off of facing? What do you think image X scale is? Image X scale is the facing of the car, your player character. Are you facing right or are you facing left? And that is basically what we're referencing. We're referencing facing, but it's not called facing because, spoiler alert, if I go into step and I say facing, you see how there's no facing? There's no facing variable by default. So we have to make a facing variable. So I came to a conclusion. Why should I create an additional named variable when I can just work with what I already have? There's no point in overcomplicating it. So, if you'll note, I also added in, because it took a little bit, so I decided to add in a bonus with tile collision. So I went and I decided, instead of driving myself nuts trying to figure out a way to make the player not able to leave the room, I would just make some tiles and make it to where the player collides with that so it doesn't get stuck in there. You don't need to worry about it being an object, so it's not going to take up. And the other great thing about it being tiles is tiles don't take up nearly as much data. It's when you have like 100 different objects, because you need to in order to create the walls and the floors and all that stuff. That's why a lot of old school Game Maker 8, not Game Maker Studio 2, Game Maker 8.1 had this problem where the floor objects would make things so much more all over the place. And that still kind of happens, but nowhere near as bad with Game Maker Studio 2. So image x scale equals -1. So that's left. Okay. So now that we know what is left and what is right, so left is D. Okay. So guess what? With left, we got image x scale equals -1. So now we're going to go to image x scale equals, well, we're starting with 1, so that means that right. We're starting with right. So when I'm facing right and I'm fully powered up, I'm going to facing 0, direction 0, direction 45. Now you remember, if you go back to the previous video, there's a chart which basically tells you all the directions and stuff of what direction the bullet is going to be moving. And then of course we have our V speed, which is the amount of speed that it's going to be using. So, and sound strike of course references the sound that it's going to make when it's created. And spry index is what the bullet's going to look like. So direction 0, and then we're going to direction 45, then we're going to direction 25, and then I put -45 and -25. Now what does that do? Well, that means that the opposite would be true. So because of the fact of we're on the forward arc, -45 is going to be, it's either going to be up or down. I mean, I could just literally copy paste it, but trust me, this works. The basic gist of it is, with the negative and stuff like that, is you're making you're making sure that the direction that it's moving is exactly reverse of what you've already done. So if direction 45 and direction 25 were in upwards direction, then -45 and -25 are going to be a downwards direction. And this is still all for going right. So when it's powered up, it's going to run all of this. What if it's not powered up? Well, if it's not powered up, it's going to do the same thing, but it's going to be direction 0, and then that's just going to stop, and it's fine. So now image x scale -1. So this is the left. Direction 180, speed 10. This is literally going the opposite. You just take a ruler and you take a chart, or eyeball it if you have no ruler, or a flat paper, and just lean up against the computer, whatever you need to do. Honestly, if you want to, if you have the money to spend like $5-6 on Amazon, go get yourself a 360-degree radius tool, and that will show you where all the directions go. I also recommend getting some sort of like paper that highlights it. I recommend like a yellow or a pinkish or a light blue, or some sort of bright color that will offset the thing, so you can put it on there and you can use that, and the little compass thing will pop more. Because you put it on white paper or black paper, it's going to blend right in and it's going to be murky. So there is that. Alright. So there we go. So yeah, that's exactly how that works right there. Now if it's fully powered up, again it's the same principle. So 160, 140. Alright. And then -160, -140. And at the very end, we have 180, which is the default shot. And everything queues up off of that. And there you go. That's literally it. There's also the tile collision coding. And for that, you set your variables up I used WASD. The original lesson doesn't do that. It uses arrow keys, but that's not what we were using before. It's not what we're going to use. Now, if this video gets, let's say, I'll be small here. Let's say if it gets 5 likes, okay? You can do that. If this video gets 5 likes, I will come back to it and I will show you how to customize your controller. But for now, just this. This is all you need. Okay? So you have var left, var right, var up, var down. Alright. So now we want whatever our layer ID is. Lay ID is a variable. These are both temps. Okay? We're going with layer tile map get, so we're referencing and making sure that it's active, and we're getting the tiles which are referenced in that specific layer. So if the layer tile walls does not exist in your room, this code doesn't work. You could call that tile, instead of tile walls, you could call it just tiles. You could call it rubber baby buggy bumpers. Whatever you want to call it. I prefer tile walls because it's exactly what it says on the tin. So now that you've referenced that, now we have that, and so if left equals 1. Alright. So if left equals 1, image X scale flip, so this is the image flip, and then we go left top, left bottom. So this is referencing the bounding box, and this is your movement speed. Your movement speed is basically in the create event, and that is how fast your player moves. And if you remember earlier when we had the X plus, this is basically doing the exact same thing. In fact, yeah, I put the move speed as 4, so there's no difference in momentum in how the object is moving at this point. The player will still move at the exact same speed, and if you want to change how fast it moves, all you need to do is just go into the create event and change that, and you're fine. So you can see collision on the right hand side, and then there's no tile block you can move, so this is saying left top, left bot, and this is basically asking if it is colliding, if there is nothing that it's colliding with. So if there's nothing it's colliding with, then those things are both 0, and therefore because those things are both 0, then X minus equals move speed. So there you go. Right equals 1. Again, flipping the image X scale. Is there a collision on the left hand side? Yes, no. We're checking for pretty much the same thing, but this is the right hand side. So again, it's the same X's being added and subtracted, Y's being added and subtracted. It's just using these collisions and using the B box. I know, you're going to ask, what's a B box? Your B box is your collision box. So every sprite has a collision box, and the object inherits that collision box the moment it gets attached to it. So there you go. That's what's referring to as collision mask and stuff like that. So instead of looking at the sprite, this code directly looks at the collision mask and asks, are you touching me? If you're not touching me and there's no thing over here, then, well, you have momentum still, at which point you can keep going. So because of it referencing the tiles and the B-box and stuff like that, it's very unlikely that you're going to get what I've seen with some other collision codes with objects, where you have the possibility of the person getting stuck in the wall. If there is no tile block, so down left, down right. If down left and down right both equal nope, then you can move. So there you go. That's how we did collision. That's how that got implemented. And now, oh, and I had one more thing. I re-implemented an old camera code, and I implemented an old script for the screen shaking. So this basically is the camera. This is from an old tutorial by Sean Spalding. If you don't know who they are, look them up. They're pretty cool. Anyways, but they did a platform tutorial, and I usually use that camera code to make things look a little bit nicer. So there's that. Alright, this is basically how it buffers. Original was 32. I decided to go 15. And the reason why is because if I have it at 32 with the way my current camera view is, it creates a visual error issue, and I need to fix that. So have all that. And this is all set to 0 for the fact that anytime the screen shake script is referenced, there's that. Yeah, see right there, X plus Y plus random range right there. That's what we're talking about. This keeps the camera in the center of the room. This follows the explosion, which gets created when the player dies. And this is the credits. And if not the credits, not the title, then all these layers have different speeds. And that's how that's going to work. Oh, and you'll want to make sure that if you're... I, by nature, just always put the camera as persistent. Just that's the way I do that. Because if I'm going to do more than one room, then I'll want to have the camera in all the rooms after the first one. So it will follow the player if the player's going from room to room to room. Because otherwise I have to create a camera for every single room. I guess that wouldn't be too bad if you had like a small game. But if you don't have a small game, and you have a relatively big game, or you have a game with multiple large levels, or you're doing a Zelda-like or something like that, then yeah, you probably want the camera to be persistent. Alright. You see how the background moves now? See when I die? That happens. As you can see, I can fire in both directions. I can't go above there, and I can't go below there. Let's see, there we go. And you can kind of see, wee, flying car. Okay, folks, that's pretty much it. I hope this was helpful. Sorry this took around 3 months longer than I wanted to. I'm happy to be back, and I'm happy to continue doing these. And I'll be just kind of on and off. So, enjoy that. Have a wonderful day. Peace.